Hello and welcome to Season 4 of the SoundStage Audiophile Podcast. For the past few years, host Jorden Guth has been learning about the who, the what, and the when of hi-fi from the pioneers who made our hobby what it is today, as well as the modern innovators who are constantly striving to push performance to new levels. That's not going to change, but this year he'll also be learning about the other two W's, where your favorite gear is made these days, and why. So with that out of the way, let's see who Jorden is chatting with this time around.
Hello and welcome to the SoundStage Audiophile Podcast. Today we are at KEF in Maidstone, Kent, England with Jack Oclee-Brown, VP of Technology. Welcome, Jack. Thanks for having us.
Thanks, Jordan. Nice to be here.
Yeah. So throughout this entire day, we've filmed some really cool stuff, some technology that we've seen and kind of experienced before, and then some new stuff. And we're going to save all the new stuff for a later podcast because we can't really talk about it now. But I think one of the coolest things, kind of visiting this factory for a second time over 10 years, there's still a lot of manufacturing that is going on here.
Yes. Yeah, we manufacture our higher end speakers here. So there's you saw the reference lineup being manufactured and the Blade 2 and the Blade 1, and we do Muons, although there weren't any being built right now today. Yeah. So we do quite a lot in those products. I mean, we can offer a kind of high level of craftsmanship, of customization, and the way they're built is a little bit different as well, which maybe is something we can go into.
Yeah, I mean, the way they're built is definitely part of the iconic design. And even I was getting shown around some of the other spaces and some of the storage spaces, and I saw some of the molds for the Blade 2, maybe
That would have been the Blade, the big one.
Oh, the Blade. And that was cool, kind of even just seeing that, the molds that were used for the original run of them before the kind of manufacturing change.
Yeah, before the tooling change. That's right. So we, originally we were making them from glass reinforced plastic, GRP, with like an MDF skeleton inside. But yeah, I mean, once we had kind of realized what the demand was going to be, we changed the cabinet manufacture method, something more suited to a bit of a higher volume. So yeah, we've been doing it differently, but yeah, we've still got those old molds. So you never know. Maybe one day we'll use them for something.
It's super cool. And it's really fun to see. And I guess, I don't know if you've been listening to this season of the podcast. One of your other engineers has, which was really cool to kind of see. It brings a joy to my heart. But this season, we're kind of focusing or trying to focus on the manufacturing elements and why things get manufactured in a certain place, in a certain way, and all that. And walking around this factory and seeing some of this stuff and seeing the blades and all that brought up so many different questions. So one of them is KEF's model range does vary in terms of where it's manufactured.
Yeah, that's right. So we're part of quite a big group called the Gold Peak Group, and in the group there's lots of different divisions, and we're in a group called Gold Peak Acoustics. That's KEF, and our sister company Celestion, which some of your listeners might be familiar with. But we make mostly consumer products that people buy and have at home, and Celestion make mostly drivers that go into either guitar speakers or they go into Pro PA. And they don't actually sell anything to kind of end users generally. It's business to business. But, within the group, both of us have got factories in the UK, actually. So Celestion have got a factory in the UK, and we've got a factory in the UK. And we use those factories for kind of low volume specialist manufacture of high-end product. And then for things where we're making higher quantity, we're generally using another company in the group called Gold Peak Electronics. So that's a manufacturing company that also does some ODM and OEM and has some engineering capabilities too. And, we partner with them for active systems. It's co-design with them. But they also have factory facilities. So they actually have a couple of those. So one in China and one in Thailand. And that's where the majority of our high-run products are made. So we have the kind of flexibility to do different quantity of production. I think that's one of the key things. So the factories, the GPE have are very geared towards making the same thing in multiples of 1,000, let's say.
Yeah.
Whereas our factories over here are more kind of tailor-making things in hundreds. And having the two together gives us kind of quite a lot of flexibility.
The best of both worlds.
Yes, I guess so. And there's a lot of overlap as well. So, often we would have sub-assemblies, we'd call them, so parts made in our factories in China or Thailand, which then get shipped and built into a complete product in the UK, or, Celestion are doing a similar thing as well.
Okay. And I guess where along in the process of designing a product do you decide whether it's going to kind of be made entirely in one of these GP factories, or where you could see some of it being made here? Or is it simply based on the quantity that you can estimate for that product?
It's pretty much set from the start.
Okay.
I mean, the way that the logistics of selecting suppliers works, you kind of have to know from the start where you're going to make something, particularly for something with like high quality finishing. So like the cabinet sourcing and finishing is, will be very different for something we make in the UK compared to something that's made by GPE. So there's that aspect. But in between different factories at GPE, there's more flexibility. Although the facilities at the factories are slightly different, we can be a bit flexible between them. But yeah, it's generally things which are made in higher quantities are made in the factory in GPE, and that's really what sets it apart. So, yeah, I mean, there's very different ways the production lines run as well, which is one thing that's maybe interesting is, so I think the GPE approach is probably more what you'd imagine a factory to be, where you have really a kind of flow line production. So you have multiple people who work together to manufacture maybe a complete driver.
Yeah.
And each operator is, sequentially passing the piece that's being assembled to the next one. And each person in the line does a different operation over and over again, if you see what I mean.
Yeah.
So that's very good for when you're doing high volume of something. And you can train then, each station where they're doing one particular function over and over again. You can make it highly specialized, make sure it's really, really repeatable. And that's great. And we get, our operatives who do that are very, very good. And the quality we get is very good with that. And you can then very efficiently make hundreds and hundreds of drivers, which are near as you can
identical,
do.
Yeah.
Identical. But then that doesn't give you the best ability to kind of adapt and make bespoke things. Whereas what you'll see if you go to the factory in the next building in Maidstone is that when you look down the production line, you'll see we have build benches. And one builder is working at one build bench, and they'll be assembling a loudspeaker from start to finish, just them doing that. So they tend to have like a pair of cabinets, all the parts they need to assemble the speaker. So from crossovers, wadding, gaskets, trim rings, drivers, of course, and any bolts and fixtures. And, from start to finish, they are putting together that pair of speakers. And the benefit of that is that there's lots of flexibility there. So typically you walk in there, you won't see them all building the same thing. So depending on what orders are coming through the factory, there might be a couple of guys doing reference, a couple of guys doing blade, and so on. Every time I walk in there, it's a different mix. So, for high value product where we're building in custom colors sometimes, we're building to order, that's a really great way to do it. And it also... it's a different way of operating. That guy building that product needs to know everything about how to assemble that. They don't just need to know one step.
The training is more in depth in the entire process. Yeah,
they know that product inside out to be able to build it. They know where every bolt goes, where everything is positioned. Everything's highly controlled as well. When you're talking about even things that would be considered not to matter, they do matter. So like gasket position, what kind of quantity to use. It's all documented and controlled. So the guy building or the lady building needs to know exactly where those things go and do it the same every time. And by having a production there where, one person is building one product, I do think that gives you a kind of sense of investment with the builder and the product, so that they, want to put something out that's as near as they can get it perfect.
Yeah.
And that's really what we're trying to offer technologically and design-wise as well, with something like a blade or a reference. So it's a really suitable kind of production for that kind of very special high-end product.
And so it's interesting. We're talking about the manufacturing. We're talking about the tolerances. So one thing that was pointed out to me is you have both like engineering references, engineering samples, but also production references or line references for the speaker. So why is there a difference between the two, and kind of what functions do they serve?
Yeah, that's a good question. So the history of that is related to the history of the reference series that KEF make. And the reference series, reference as a name for a hi-fi product is like ubiquitous, right? Most manufacturers make something called reference. But for KEF, we've been making a reference series since about 1970. And the original reason it was called the reference series was because of the production method. So the reference name was chosen because of what they decided to do with the way they would do end-of-line testing.
Oh.
So, around, I know the exact dates escape me now, but
totally okay.
KEF highly invested in the 70s in computer measurement of loudspeakers. And we were pioneers in that, one of the first companies to do that. And along with that came the possibility to have better quality control. And you imagine you're trying to do quality control of loudspeakers before you could store all the measurements digitally. But suddenly you could do it. So you could do production consistency tests.
Yeah.
So everything coming off the production line, you had the ability to measure it and check it was okay. And with that came the question, well, how do you do that? And the solution that KEF came up with was, well, we'll have a reference loudspeaker. So literally a loudspeaker that lives at the end of the production line, which all the others are compared against to check they're okay. And we call that the line standard.
Gotcha.
So, and as a bit of an extension to that, who should prepare that sample? Well, at KEF, the answer was the engineering team that developed the loudspeakers should prepare that sample. So at the time that's done, the engineers didn't just make one, they would tend to make two. They would keep one as a reference for their own use in the lab, and that would be called the lab standard. And the one that went to the production line would be called the line standard.
Gotcha.
So why do two? Well, it's kind of like redundancy. In a production environment, you never know. Somebody can walk into the speaker and break it, and we don't want the production to stop. So in that scenario, we could switch them and fix up the broken one. It's also very useful for the lab to have a standard as well. So if we're not sure about a particular spec and want to check it, we can take the lab standard, we can get it in the chamber, measure it. Or if you're developing a new product and you want to benchmark it, you've got the old one there. So that's how it evolved. Now the thing is, nowadays, it's pretty standard, actually. That kind of very special production technique and the reason behind the reference name, that's pretty much what the industry does now. And in other companies, you won't hear the same terminology. Sometimes you quite often hear this idea of a golden sample being used. Yeah. But it's the same thing. And I do think that KEF were the first company in the business doing this on the production. Now, these days, we do it on all the ranges, R series, Q series, everything. We have a line standard and lab standard. And even if we've got, manufacturer in another country, we would have a golden sample selected at the, say GPE's production line, so they can do the same kind of end-of-line testing that we do.
And that's actually kind of going into the next question, which is when we talk about the differences between, I'll say your quality control, because your quality control is known in the industry, I would say, as like extremely high. Like KEF, in terms of quality control, that's one of the benchmarks things. When you get a set of LS50s, you could be sure that another set of LS50s is pretty much spot on. So how does that change whether you're manufacturing in England or China or Thailand?
Well, it's in terms of actually quality control, there's not a huge difference, but I think along with that, you get quite a lot of tricky questions. So if you want to get really good quality control, in a way, it's quite simple. You just have very strict criteria for whether you reject or accept the product at the end of the production line, right? Yeah. So we have our golden sample of what the speaker should do. We have the one that's come off the production line, and then we compare them, right? So you can compare things like frequency response, distortion, impedance, and it's up to the engineering team, along with the factory QA team, to kind of agree on what those specs should be. And I wouldn't say, it's always, this may be a stereotyping, but what you generally find is the engineering team who've lovingly developed the product want the controls to be as strict as possible.
Yeah.
When we're like saying, oh, everything should be like this wonderful speaker we've prototyped.
Yeah. Plus or minus 0.05.
Yeah. And then you can imagine if you're a factory QA engineer, you want to make sure you can get good yield.
Sure.
You don't want to be throwing away a load of speakers at the end.
Well, especially at the end of the line. Yeah.
And so in terms of actually putting out good product, it's getting a good end-of-line test, which is quite tight. But the more difficult question is, how are you going to make sure your yield's okay? And I mean, in terms of like us compared to the industry in general, I do believe that most big brands who are producing a significant quantity of speakers will be testing all of their products at the end of the production line very thoroughly. So I don't think we're exceptional in that regard. Possibly our tolerances are tighter. But really the key to that is in trying to design loudspeakers and drivers where they can be produced and have good yield at that tighter tolerance. Yeah, and I think some of that comes down to decisions you make about how you develop the drivers.
And I was going to actually just ask about this idea of like, is there technical choices that you make that impact the quality control and the manufacturing? Is there technology that you would like to implement that you just know the manufacturing process isn't at a point yet to be able to support it?
Yeah, I mean, there's certainly... some of the decisions we've made in the last 15, 20 years about what materials we're going to use for driver diaphragms and so on has been driven by us wanting to have more consistency. So when I first joined KEF, we were using a lot of molded polypropylene cones, for example.
Okay. And that was about 15, 20 years ago now.
20 years ago now.
Yeah, wild.
Yeah.
Congrats.
Long time ago. Yeah, so we were using generally plastic cones, molded polypropylene. And one of the things that we used to find with that is that they were quite sensitive to the material. So, you can imagine if you're a plastic supplier, you want to be supplying tons of material at once. That would be a great deal for a plastic salesman. Whereas if you look at like a whole lifetime of one of our products, the cones are very light, right? So you could take the whole lifetime of a product and it would be a fraction of the total, order from a plastic supplier. So what we often found was happening is that we would go to some place that could tool our cones and produce our cones and select a material that we would use in a prototype that we like the behavior of. And you might find that over time, it slightly changed. Maybe the cycle temperature they're using in the machines was different. Sometimes the plastic blend that we'd specified just wasn't available, or you couldn't afford to buy, a ton of the new stuff.
Yeah.
And this kind of thing would cause quite big problems because you just would have to then accept that the response is going to change, the characteristics are going to change. And it was always kind of allied to that. But if you have something where the loudspeaker design is so sensitive to the material properties, it kind of goes hand in hand that it's going to give you difficulties also when you're prototyping. If you can't source exactly the same plastic in the UK that they're going to be able to source in say China or Thailand, you're not going to get the same thing. It can also, be a really big problem trying to do FEA simulation. So if you've got blends of plastic where the difference between blends can make a difference, then you have to characterize all of those materials to use them in your FEA. And it was something which we discussed quite at length and was one of the driving factors behind our reason to go to mostly aluminium cones. Actually.
Oh, interesting.
So the combination of, wanting to avoid these issues with production consistency and simplify our simulation was behind that. And it's been one of the things which has really, I think, helped our production consistency considerably. And so with a pressed aluminium alloy cone, you can switch the alloy, and as long as you're sensible about the new one versus the old one, we can get still production consistency if we have to.
Yeah.
So that was a key step. And we also, if you look back a little bit further at things you've seen today in the KEF Museum, you'll notice we were using fabric tweeters, and that similar issues there, that they tended also to be doped with adhesive as well. And then you get things like, well, the quantity of adhesive has a big effect on the response. So that can be something that midway through your production run, it can change suddenly and cause you problems. But yeah, again, we use metal, generally aluminium tweeters, which gives us some, we didn't just select it for that reason, but it was a consideration. So yeah, there's a few different aspects. And it extends into some other areas as well, with motor system design a little bit. And then there's a lot of hand-wringing that goes on in the kind of mechanical design process to try and make assemblies that you can put together consistently and repeatably. So yeah, I think it's one of those things that ultimately the pass or fail is at the end of production line. But if you're going to get good yield at tight tolerances, you've got to be thinking about it way before that. I mean, there's no point in just saying to a factory, reject everything that's outside plus minus half a dB, because somebody's got to pay for the bill for all the ones they reject.
Now, is there, and I don't know if you guys do this, do you manufacture the same speaker in, let's say, your China facility as well as your Thailand facility? And then would people notice a difference in the speaker there, or are those lines kind of independent at the moment?
No, we've had, say, products which have initially been made in the China facility that have then subsequently been made in the facility in Thailand. Yeah. And, we are part of that switch process to make sure from an acoustic point of view, it's up to standard. Yeah. And we work very closely with GPE when we do that. Alongside what we're doing, which is mostly focused on performance. Sure. There's a similar consideration for the cosmetics as well. With our design team, which is based in Hong Kong, they would make sure they get samples of, say, cabinets, of parts that are being made in the Thailand factory and check they're up to scratch. I'll focus maybe on my answers more on performance, but there's a similar kind of approach with cosmetics too. So when we have our design team approving colors, they will also have a range of acceptable colors and give examples to the factory. The tolerance of that color and stuff. Literally with samples of, we make some interesting color cones and interesting paint finishes, and, you don't want any interpretation there about what's acceptable and what's not. That generally parts like that are being made by third-party suppliers. So, we don't want suddenly to have 1,000 cabinets arrive that are slightly the wrong color of green or something like that. So there's a lot of work that goes on that's maybe not given enough credit, that makes sure that, it looks very consistent as well as sounding very consistent. So. That's really cool. And there's so many kind of avenues that we could go down this, because, KEF makes everything from smaller speakers all the way up to the Muon. Yeah. And then also headphones. Yes. So is there a lot of consideration in terms of where the headphones are made and how those are made? And is that like drastically different than the process for speakers? It's actually very similar. I think generally the same things I've mentioned apply. So, the way the industry standard is, you select golden samples for performance. And then for cosmetics, you have kind of acceptable limits of what's okay. I think one area where headphones does present a bit more of a difficulty is the variability of the measurements. So even if you're doing measurements of a single pair of headphones, you will find if you take it off the fixture and put it back on, they'll measure slightly differently. And that's just because it's very difficult to put them back on in a consistent position every time. In the exact same space. And yeah. So in a production setting, you haven't got time for somebody to be fiddling around with the position so that you can get like a pass fail, So that's a bit more challenging. So generally you can't achieve the same kind of tight tolerances. And I think, part of the challenge there is just on designing good jigs and fixtures so that you can kind of minimize variation just from placement. But no, it's very, very similar in basically every other respect. speakers are generally easier. And I mean, I should say that one of the reasons that the golden sample or line standard in KEF terminology is used is because it takes some of the difficulty away from the acoustic measurements. So measuring a loudspeaker without the influence of the room or the placement is very challenging. And, you've seen the anechoic chamber we have.
Yeah.
And I know that you also go to NRC to do your measurements for review. And in a production environment, you don't normally have access to an anechoic chamber like that. Now, the benefit of having a golden standard is you don't have to get absolute measurements anymore. So what I mean by that is if you're doing lab grade measurements, say, you're looking at, what is the frequency response without the influence of anything else? With calibrated microphones, you want to know what's the sensitivity, in SPL per watt, whatever like that. If you're doing relative, you're just saying, is the loudspeaker that I've just made close enough to the golden sample?
Yeah.
And this takes out a lot of the influence of things like placement or measurement environment, because you can guarantee pretty much that the effect of the environment would be the same on both speakers.
Gotcha.
So it takes that out of the equation. So that's one thing that makes production measurements, achievable, really. If we were always trying to do it in a kind of a lab kind of way, it would make it very expensive to have these kind of really quiet lab facilities everywhere in our production. So the golden sample method is really widely used across many industries, I think.
So something that just kind of came to mind, and I don't know if this is a practice that's actually used, but do you ever kind of double check the measurement of the line reference or the engineering reference? So I guess what I mean by that is, like, we were looking at the blades earlier, and that's where we kind of saw this line reference, and I was like, oh, that's cool.
Yeah.
Does that ever get checked just to make sure that the speaker, the line reference itself, is actually performing the way it should?
Yeah. So the process with our production measurements kind of has that check built in.
Okay.
So let's say you arrive at production facility on, tomorrow's Tuesday, so Tuesday.
Yeah.
And we're going to be building, say, reference one. So the QA operator, the first thing he's going to do is get the golden sample of the reference ones. And then he needs to measure that there and then on the day. And so, that the reason we do that is because if there's a change in the test equipment, say somebody slightly moved the microphone, something like that, we want to discount that from the measurements. That's not important. What's important is the production the same as the standard? So he will do the measurement fresh every day. And when he does that fresh measurement, it will be compared against the documented.
Gotcha.
Right. So if, something happened and, a driver blew for some reason, that would be picked up.
Gotcha.
At the beginning of the day when you load in the measurement.
Yeah, the check and balance is right there. You can see black and white whether or not it's actually close to what was documented.
Exactly.
Gotcha.
Yeah, so you can pick that up. In terms of our measurement system, we have a site-wide database. So all of the measurement software that we're using is in-house, including the production stuff, including the stuff in our anechoic chamber. So whenever you do a measurement, it gets uploaded onto a database, which is on one of our internal servers and is given a unique measurement number. For production, it then has either the serial number of the product that's coming off the production line, or it gets stamped with, okay, this is the line standard if it's the first one of the day. With our R&D, we can put in like a comment, what we're working on basically.
Yeah.
And a bit about the measurement maybe. But, our database, I can show you later, but it's like hundreds of thousands of measurements now. But so if we suspect that our lab standard has been damaged somehow, we can find a previous measurement on that within seconds and do the same measurement again and check it against it. So yeah, the documentation of the measurements is part of the whole system. I mean, and it's quite cool. We get, customers who say they receive a pair of speakers and they maybe have a query about them. We can look up the measurements and say, okay, here's your measurements. That, because if we have the serial number and they were made here, we can look it up in the database.
So does KEF support have access to that as well, or would that typically be like a process where they would go, oh, something's weird or I'm curious about this, and then KEF support kind of hooks in with you. And
they probably don't know they have access actually, but it's on our kind of wide area network, so they can get access. But normally in that scenario, it doesn't happen a lot. If somebody has a query, they'll normally ask the engineering team.
Sure.
We can look it up for them. So it's quite nice. And if there is an occasion, I must say it's rare, but if there's an occasion where somebody's like damaged a speaker that's been made here, they will come back for repair. And if it was something that's on our database, we can repair it and then compare it against what it was like the first time.
Oh, interesting. That's cool.
So it doesn't often happen. We're shipping worldwide here, so it would have to be something that then comes back for repair here, which isn't always the case.
Oh, that's fair.
Yeah.
That's really cool. And there's so much other stuff that we could talk about, because even you kind of hinted at it, the idea that you do a lot of the software in-house. Alex, one of your engineers, was showing me the system in the anechoic chamber and was kind of explaining some of the process that went into that, which is fascinating. But right now we're kind of at the roughly 30-minute mark. Let's pause it here. Let's call this episode done, and maybe another episode that won't get released until quite a bit in the future. Maybe we could talk a little bit about that and some of the other cool new stuff that's coming up.
Let's do that. Okay, Jordan. Thank you very much.
Thank you so much. Thank you.
You're very welcome.
And take care, guys. All the best.